Hi everyone. Today we are going to learn about additive property of geometric distribution. Okay, so first we are going to write the statement. So we all know that additive in the sense nothing but the sum, SUM. Okay, yeah, the sum of an independent geometric variates is a negative binomial variate. Okay, or else you can say this one: if x1, x2 and so on xn are n independent geometric variates also you can say, or else variables. Okay, variables with parameter with parameters p, then summation I equals to 1 to n xi follows negative binomial distribution. Okay, so we have to prove this one. That means we can say that additive property is not satisfied in geometric distribution. Why? Because if additive property is satisfied, here the sum of an independent geometric variates is also a geometric variate we have to get. But here if we take any two geometric variables, if we add them, we don't get what geometric, we get what negative binomial variate. Okay, so that's why we can say that additive property is not satisfied in geometric distribution. So when additive property is not satisfied, at that time we come another topic we come across is lack of memoryless property. Okay, so we'll discuss in the next video. Okay, what is lack of memory property. So now we'll prove this one. Okay, so proof. So as we all know that when we are going to prove additive property, we have to consider moment generating functions. Okay, yeah. Given that x1, x2 and so on xn are n independent geometric variates. Okay, geometric variates. Okay, so we know that moment generating function of geometric distribution is mx of t equals to p into 1 minus q into e power t whole power 1 is the moment generating function of geometric distribution. But here we considered n independent random variables. So that's why mx1 of t equals to p into 1 minus q into e power t whole power minus 1 and mx2 of t equals to p into 1 minus q into e power t whole power minus 1 and so on. Mxn of t equals to what? P into 1 minus q into e power t whole power minus 1. Now we have to consider m x1 plus x2 plus and so on plus xn of t equals to mx1 of t into mx2 of t and so on mxn of t. So mx1 of t in the sense what? This one. P into 1 minus q into e power t whole power minus 1. mx2 in the sense this one. P into 1 minus q into e power t whole power minus 1 and so on. mxn in the sense what? P into 1 minus q into e power t whole power minus 1. So if we see here, we are having 1p and the next second p into p square and so on like that. This is nth term if we consider. So what we get here? P power n into 1 minus q into e power t whole power minus 1 and so on we get. So what we can write here? Minus n we can write, no? So that means what? M summation xi of t equals to, here we can write in place of this, we can write what? Summation. So m summation xi of t equals to p power n into 1 minus q into e power t whole power minus n, which is moment generating function of negative binomial distribution. That's why here we have written the statement, the sum of n independent, here we have written the statement, the sum of n independent geometric variates is also a negative binomial variate. So that's why we got this one, which is moment generating function of negative binomial distribution. Okay, so this is about additive property of geometric distribution. Hope you all understand. So if you are newly watching this video, please like, share and subscribe. Okay, thank you. Have a nice day.